G'day, you're watching the Aussie BIM Guru. Today I was going to do a demonstration on how to create custom hatch patterns for Autodesk Revit, which can be quite a complicated challenge for some people. So I was going to run through 6 what I would say are quite easy methods of how this can be achieved. So I guess first I'll demonstrate what hatch patterns are, for those that aren't aware. So they're basically files that are referenced in Revit. If you go to Manage Additional Settings, Fill Patterns. So what we have here are native fill patterns in Revit, which are typically cross-referencing a custom PAT or pattern file, and that is the hatch pattern we're talking about. It's important to note that some hatch patterns aren't controlled by an external hatch pattern file. They're controlled by a local definition in Revit. However, these are typically limited to parallel line patterns and cross-hatch patterns of regular spacing. So for most cases, this won't suit. For example, here we have a concrete pattern, which is controlled by an external pattern file. So it's important to understand the difference between what I'm going to be referring to as model and drafting patterns. So when I refer to model patterns, that's a real-world scale pattern, and a drafting pattern is what I would call a paper scale pattern. So basically, as a drawing scale changes, the model patterns will remain the same size in the real world, but they'll change on the paper scale. But the drafting patterns will remain the same on the paper scale, but won't bear relevance to real world scale. So a quick demonstration of what this means. So in 3D, in this view, I have a model pattern applied to a wall. It's a brick pattern, and I have a steel pattern applied to a wall here. Currently I'm at 1 to 100. If I go to 1 to 10, you'll notice that the brick pattern didn't change, but the steel pattern did, and that's because the scale changed. So basically this brick pattern will always be the same dimensions on a drawing in respect to real world scale. So it's quite important to understand. So the first method we're going to run through is writing a pattern. So a pro is that it only requires Notepad, and it's only really suited for basic patterns like bricks and parallel lines. Sorry, got my zoom messed up there. Alright, so in principle what we're going to be looking at now is how to make a brick pattern. So each line of a pattern file looks something like this red or blue line. It's up to 7 numbers. Each of them represents an aspect of that pattern line. So let's start with the red lines in this pattern. So in principle we have lines continuing to infinity, to the left and the right, spaced at 200 millimeters. So those 3 numbers basically represent the angle that the line is at, its X and Y position that it begins at, its offset in the perpendicular direction, so that would be how far forward it's offset. So that would be for the blue lines, which we'll refer to shortly. But in this case, there's a parallel offset instead. So what is the spacing laterally between the lines as it repeats through the pattern file? And then also what portion of the pattern is solid or empty along that line. In this case, it's a full line, so there is no requirement to add how much is solid or empty. The pattern file will assume that it's a continuous line if you leave those 2 numbers out. Whereas the blue lines, they're a bit more complicated. So in this case, the pattern actually only really requires 1 set of lines to achieve those lateral staggered lines. In this case, you can see that the lines are at 90 degrees. They start at the same position. However, they have a perpendicular offset of 200 millimeters forward, and they have an offset in the parallel direction of 200 millimeters to the right. And then there's a 200 millimeter solid and a 200 millimeter empty portion of the line as that pattern repeats, which is what achieves the staggered effect. So in a pattern file, that would typically look something like this. So typically a pattern file will have the version of the pattern file, which has been 3.0 for quite a while now. The units, which for me, because I'm in Australia, are millimeters. You could have inches if you were in the United States, for example. And then typically this line here is really just a name of your choice. This asterisk basically is telling the pattern file to expect some free text until it hits a comma. So you could call this whatever you want. It's usually good to call this either the same thing as the pattern name, or the name that you'd want the pattern to be at as in Revit when you bring it in. And the last line, which is absolutely critical, is whether it's model or drafting. So in this case, you can see this is a model pattern. And this is how Revit understands whether it should be thinking of this in real world scale or as a paper scale element. And you can see these 2 lines here. So they're basically the two line definitions. So you could have many lines in a pattern file. It could be far more complicated. It could be a lot of repetition of elements to achieve a much more complex pattern. But in this case, this is quite a simple pattern that it achieves. So let's say we've got this pattern, we've built it, we've written it, we're happy with it. So how do we bring that into Revit? So under Manage, Additional Settings, Fill Pattern. So here's where you can see drafting and model patterns are separated. In this case, we're going to go to Model Patterns because we want to create a model pattern. We're going to make a new fill pattern. So this is where we could do something like a 50 mil spaced lines, but we're going to go custom instead. And we're going to go browse. We'll navigate to that PAT file. We'll open. And you'll see it's already showing us what our pattern looks like, which is great. Sometimes if you do load the wrong type of pattern by accident, such as a drafting pattern, it will typically tell you no model or no drafting type patterns found, which is a good sign that the pattern is set the wrong way. If you get a strange preview like this sometimes, that might mean that your scale or your units are incorrect as well. So be sure that your pattern is written to the right scale in respect to drafting or model space that you're working in. Typically drafting patterns will have much smaller lines because they're dealing at a paper scale rather than real world. You can actually scale patterns as well, so you could double that pattern in size. If it's possible to scale it logically, then it's okay. Typically I avoid this because it's easy to understand the pattern in definition if you need to rebuild that pattern again. Once we go okay on that, you'll see now we've got a blockwork pattern available. So I just got a cat jumping on my lap. Say hi to Eddie. Anyway, back where were we? So if I take this brick wall, for example, and I want to apply a blockwork pattern to that wall. Sorry, he's back. Let's just go to this brickwork pattern here. So we're going to apply a surface pattern to this material. At the moment, it's a 75 by 225 brick. For this case, let's actually go and find our blockwork, which we added here, blockwork 2, I believe we called it. I think so. There's a couple of copies of this pattern in the file, I think. That looks like it. Cool. So if we go okay that, okay that, okay that, you'll see that our pattern file is coming through. And if we change our scale, you'll see it's remaining the same, which is pretty much what we intended. Likewise, you can also bring in drafting patterns similarly. It's pretty much the same workflow. Custom, browse. Sorry, I'm just defending myself from a cat here. So I believe I've got an earth pattern here, and you can see it's coming up the same way as it would. And if we go okay that, I already have one in here with the same name. Let's call it 123, for example. And there you go, you can see there's that earth pattern there. So that's pretty much how to do custom written patterns. But obviously it's only really suitable for quite simple patterns because the more complex the pattern, the harder it is to write. So it's a limited workflow. So I've been to a demonstration. So an alternative method, the most common pattern that I tend to have to make for people that I work with as a BIM manager is a brick pattern. And it's usually a staggered brick pattern as well. So what I've actually done is I've actually written a small Excel script in the past, which has helped me quite a lot. So if I open this file here, and I will share this in the description of the video. So pretty much what you've got in this file is you've got two options. You've got staggered brick with mortar or staggered brick without. So you can do, say, a 76 by 230 with a 10 mil mortar, or we could do a 86 high. Sorry, I'll just enable editing. We could do 86 by 240 to include mortar as well. And these lines on the end here are basically representing what your pattern needs to be. And all you need to do is copy that. And you'll need to open a template or a hatch pattern that you want to overwrite. For this case, I usually keep a drafting and a model template close on hand. And basically it has a section where you paste in the line numbers. So let's just put in a description and we'll call this 76 by 230 including mortar. And that is basically our pattern file. So if we go to, you have to always go all files, otherwise it will save it as a text file. And let's just call this brick test. So if I go back to Revit, I'm going to manage, additional settings, fill patterns. This was a model. Actually, I used the drafting pattern template for that, didn't I? So all I have to do is go model. So it's probably a good thing that I did that. It shows you just how easy it can be to work between those two types of templates, especially if you make a mistake like I did. It's been a long day. So if I go to model, new, custom, browse, and I'll go up to method 1, brick test. And there you go. Actually, I did it with the mortar, of course. So this would be a 10mm mortar. So if I go in here, edit type, go back to this material as a test, and I go to this, you will see that you will get a nice and accurate brick pattern, including the mortar line, which can be great when you're trying to set out bricks quite accurately in a project. Not a lot of brick patterns will include the mortar, so that can be helpful. But alternatively, there is also a section to do one without the mortar if you choose. So I will make that available. It's quite a helpful file. And I found that that's helped me a lot during my time as a BIM manager. Okay, so I think we've got on to the next method now. Cool. So the pro, it does brick patterns. The con is it's only really for staggered bricks. You couldn't do like a Flemish bond or a more heritage or custom style brick where you might have 1.5 bricks per space. So the second method, which I use quite a lot as well, is to harvest the Autodesk pattern files. So when you install AutoCAD or Revit on your computer, you will end up with a couple of files. Sorry, I'll just navigate to the folder with them. So harvest. So I've just set up a couple of shortcuts here, but in principle, typically Autodesk will be under program files in your C drive. And if you just do a search for .pat, you will see a whole bunch of files come up. And the one that you want is called, depending which program you're in, it's either acad.pat. In this case, I'm in the Revit file folder, so this is revit.pat. But likewise, if I was in here, sorry, acad.pat location, sorry, another cat on my keyboard. Just close these. acad.pat, come on. Alright, and likewise, search for .pat. You'll find this file, acad.pat. So I've taken a copy of these two files and I've moved them to my desktop. It's good that you don't edit the actual one because you might do something quite critical to the file. And both of them typically warn you not to edit the file locally. But if you scroll down in there, what you'll find, they're big files, so they can be quite slow. So in the case of Revit, I might just open AutoCAD's because it's a bit faster, I think. It's a bit lighter. So basically you'll find stars with pattern names. And from there you'll find pattern numbers. Sorry, another cat. Say hi to Aussie. Cheeky. Actually, that's Eddie. So if I take these lines here, move this out, you can see I'm actually pretty much getting definitions for patterns in here. So all you need to do is take this, copy it. You may need to note the units because I believe that AutoCAD might be in inches in the pattern file by default. Usually there's references at the top of the file as to what units they're in. I don't think this one references. I think because this is from the metric version, I believe it's in a metric format. But if I take that material that I just got there and I go back to my drafting template, I'll paste those values. Let's just leave it as description of pattern. And we'll just save that back to, I'll just put it in the demo root folder. We'll call it drafting template.pat. That will give us our pattern file. And if we go into AutoCAD, fill patterns, drafting, custom, browse. You can see it's quite a methodical workflow once you're used to it. And there we turned out we copied a concrete pattern there. But you can see that's one way to also extract patterns as well. So that can be really helpful. One thing you've noticed as well is when I'm opening PAT files, all I have to do is double click them and they go into Notepad. By default, your computer probably won't do that. What you might need to do is right click, open with, and you may need to tick on this box here that says always use a selected program to open this kind of file, and you'll pick Notepad, which is the only file reader that typically will read PAT files on Windows out of the box. Okay, so that's that's another option for how you can extract Hatch pattern files. As a BIM manager, I always recommend that a really important task for a BIM manager is to actually extract all those patterns so they're on hand, ready for use in other programs. It'll be very helpful. And you can see there's a whole bunch of patterns in these files that you can get your hands on that you're probably quite familiar with from your AutoCAD days, potentially. And the pros, you only need Notepad and Autodesk. However, it's only for the patterns that are provided within those files, and they can be quite large and hard to extract. So the third method is an external tool which I've come across quite a while ago. I think it's from 2012, and it's called Hatch.VLX. It's a routine in AutoCAD which will let you basically draw a hatch pattern. And credits go to Blade and Gradiv, who wrote the VLX routine. It's been made public, so I will put a link in the description after where you can download this. And in principle, what happens is you draw a pattern in a tile, and then it basically previews it for you, and then you can convert it to a hatch pattern. So I'll just show you really quickly how that works. So if I go back to AutoCAD, so I've actually already loaded the routine here, so I'll just start a new file so that you can see it from the start. AutoCAD ISO. Okay, so what you need to do with the VLX is there'll be some steps you have to follow in order to run this. Typically you may need to allow apps to load into AutoCAD. I'd recommend reading the tutorial on the page for this VLX that I'll put in the description for how to actually boot this up. But in principle, it should boot up this window here once you drag and drop it into your space, and it will prompt you to say DHA. So if I go DHA, I get this window that comes up, and this is all custom. This is part of it. It's actually by Eduardo NJM as well. That might be the real name of the person, possibly. Okay, so typically I just say all for the type of things we're drawing. You can say how big the space is that you're working in. Unfortunately, it only is a square, so that can be quite limiting. It has to repeat on a square pattern. Scale factor is typically 1. We're typically drawing for Revit, millimeters, and let's say in this case we're doing a drafting pattern. So what I usually do at this point is I go cancel. This is our chance to draw. So let's just draw a couple of fun shapes and see what happens. So I'll just draw this and a couple of lines. Cool. So when you're happy with that, just go DHA, go select. Typically it's selecting everything automatically that we've drawn in that space. So we'll go enter. Before you write the pattern, you get a chance to view it as well. And there you go, that's what the tiling of the pattern will look like. So we'll go enter and we go write. And at this point it's prompting us to basically save our PAT file, of which we can just save to the correct directory, which is AutoCAD demonstration. We'll just call that drawing3.pat. If I go back and I open up that file, I believe it comes ready to go from what I recall. I don't believe there's anything you need to do beyond that. Yep, so you've got drafting, millimeters, 3.0. And you can see there, it's actually a very intense hatch pattern. There's a lot going on. And the reason that is because it's trying to draw curves, and Revit's not good at actually handling curves. It actually approximates curves typically. It actually turns them into a lot of little tiny line segments, which you'll see here. So we'll load this in. Pattern is too large, try decreasing. We may need to change our scale. I believe it's off by a factor of 100, so you may need to actually scale down when you do that. So I think I've drawn it quite large, technically, but I'll scale it down by a factor of 100. And let's just override this element with that pattern. And there it is. Again, the scale factor is quite off by the looks of it. It's actually very hard to see it. I think I've drawn it at the wrong scale. But I'll try overriding one of these. And if not, I'll just recommend that you all give it a try, because I've probably forgotten how this thing works a little bit. Drafting. Yeah, I've made a mistake with this thing, I think. It's not quite working. Try 0.1. Okay, that looks better. Okay, so it isn't quite coming in, but there you go. So that's the pattern coming into size. So I just had the scale factor a little bit off, but I believe that's because the routine is expecting me to draw this a little bit smaller. So I think I'm probably drawing in 100, and my units are probably millimeters. So I'm drawing a little bit too large. So in that case, it's good to think about the scale that you're drawing at for a drafting pattern versus a model pattern. But you can see there that that's another way to get our hatch pattern into Revit, as beautiful as it is. So that's draw hatch. So the pro is if you can draw it, you can hatch it really. But the con is it has to fit in a square. So it's not good for things that tile quite awkwardly. So sometimes things won't tile on a square basis, they'll tile on a rectangular basis, for example, such as parquet flooring. So method 4 is another routine in AutoCAD called getPat.lsp. It's a Lisp routine in principle, for those that are familiar with them. And credits go to T-Square Graphics for this one. I'll put a link in the description again because I've made this public. So if we just go back into AutoCAD, so I've got a file here with some drafting patterns. And you can do this for model patterns as well. So let's say I need to get this concrete pattern. So what I can do is I can take my LASP routine, so getPat.lsp. Similarly, I'll drag that on. There we go. It prompts me to type getPat to start. And one of the things about this routine that I've learnt you need to do is once you go getPat, you actually need to do a save as, and that tells the file where you want the pattern files to be saved to, which is a little bit awkward, but it needs to be done. So we'll click, it will say that it's written fill pattern 2, and we'll just navigate there, and there's our fp2.pat. So there it is. Obviously it's not quite ready. You can see there's a couple of things wrong. So one of them is that there's nothing at the top of the hatch pattern. So what we need to do is go back and we'll get some of that template information to put at the top of our hatch pattern. It's obviously called FP2 as well, which probably isn't quite what we want to call it. So in this case, let's just say we're going to call it concrete 1. And then you can do a save as, all files, and you could rename that to anything you want. So it could be concrete2.pat, even though we've called it concrete 1. And then likewise in Revit, if you went fill pattern, drafting, we'll just make a new one, custom, browse, concrete 2. And there's our concrete pattern. So it's been fully extracted from the CAD file, and it should be the exact same scale as well as the source. So that's really easy to get a hatch pattern, and there it is, an exact match. So that's a really handy routine. I find that one can be quite useful because a lot of the time you'll have DWG files, but you may not have Revit or pattern source files that you can get. And the good thing about the program too is you can sort of just go to town. Once you go get pat, you can enter to use the same command, enter, and you can literally just do that for as many patterns as you want, and then once you're finished you can go and actually clean them all up. The only hard part is that you may not remember what the patterns were because it only calls them FP3, FP4, etc. It doesn't give them a proper name, so you may not remember which one was earth. So sometimes I clean them as I go when I use that method. That's the one I recommend for BIM managers who are, I guess, updating their hatch pattern library. If they have a good source file, that's the fastest way to do it, I've found. And that's pretty much all the methods that I'll demonstrate today. There are some alternatives. I might just quickly show you here. I was talking about curves being problematic in hatch patterns before because of how Revit deals with them. You can sort of see here what I mean. So this is a hatch pattern that looks good from a distance, but when you get close, you can actually start to see Revit's actually faceting most of those curves. For people that know computers and game design and how meshes work, you will know that there's typically not really such thing as a perfectly curvilinear surface or line. It's always faceted, approximated, or triangulated to some degree, but Revit makes it painfully obvious sometimes. You can see here some of these circles have actually feathered after each line because Revit's hit its minimum line size for those segments of the circle, and it actually hyperextends them to reach its minimum size. So just be aware of that when you're doing curved surface patterns. There is, however, a great program that I've been experimenting with. It's part of a package called PY Revit by Hassan Around Najad, who's actually built an amazing package. And basically, if you can draw it, you can hatch it, even if it's a rectangle. And it can actually deal with curves as well. So there are some video tutorials where he sort of demonstrates his package in action, and it's quite impressive. I think it does still approximate the curves, but it's much less obvious the way it does it. It seems to approximate things much better. It must literally work to the smallest possible line segment, I believe. So if we were to look that up, I won't demonstrate it here just because I don't have it installed on my machine, and I'd rather that he get some exposure as well for making such a great tool. And method 6 is there's a couple of other tools out there. There's one called Hatch 22 and there's one called Hatch Kit by Mertens 3D and Cadro. These were sort of the original players in the hatch industry when I was first getting into Revit. The PY Revit package has only come into play recently. So there's a lot of legacy with companies that have bought this and used it. But that is actually the downfall of the programs. They cost money. So a lot of people, that's their barrier, because patch pattern creation isn't a high enough priority for their company to pay for it. But they are very easy to use and install. So if your company is considering that they need something to speed this up, it's a viable option. So there'll be some links in the description. There'll be some template files for patterns, drafting and model that you can start with. There'll be my brick pattern generator, which I wrote myself in a Google Drive folder. I'll send links also at the bottom to some of the routines I discussed because they're public, and just some further reading to the PY Revit and the Hatch 22 and the Hatch Kit websites. If there's any questions, feel free to put comments down, and if there's any suggestions for future videos, just let me know in the comments, and feel free to follow, subscribe if you're interested, and I look forward to seeing you next time. Thank you. Bye.